Welcome to everybody who's joining the webinar. Thank you for coming along this evening. This webinar is, well, just a little bit about Soils for Life. Our mission is to support Australian farmers to regenerate soils for resilient businesses and landscapes. And we have a small not-for-profit team, a small team. We've been running about 10 years, 7 equivalent full-time staff across Australia. We don't give advice, but we do focus on the experience of farmers. We've produced a lot of in-depth case studies and are working with farmers in groups. We're working to realise a world where healthy, regenerated soils and landscapes support profitable food-producing businesses, thriving and resilient regional communities, and abundant, nutritious food. It sounds like a lot, but we believe in it, and that's what we're trying to do. This webinar is about digging into soil health, and we have a particular mission to support farmers to share and learn from each other. Just a little housekeeping. Pop any questions that you have in the chat as they come up, but please stay on mute. At the end, we'll have a Q&A session where you could ask your question verbally, but when you're not talking, please stay on mute. And as I said, leave your camera on. That helps us tell how we're going with our presentation. And we'll try our best to keep us to time. So forgive us in advance if we have to cut anything off. This webinar is being recorded, and we will release the recording in due course. Just a little bit about what we're going to cover. I'm going to give a very brief overview of in-field monitoring, some of the history and how it's used. We're going to hear from Sarah Fee, our agroecologist, about how she uses it in cropping systems. We're going to hear from Campbell Mercer from Manna Hill Estate about how he uses it in his olive orchard. We're going to hear from Bert Matthews, how he uses it in dryland grazing system. And then we'll be looking at our question and answers, which is the part I'm looking forward to most. And what you can see on the left here is one of our previous colleagues, Daniela, just talking through what she's seeing in the soil there at a field day that we ran. In-field observations have been around for a while, and they are used by scientists. This scientist we can see here is David Tongway. He worked with the CSIRO, and with a few other people, he developed the landscape function analysis process to check rehabilitation of mining sites to ensure that mining companies were sticking to their commitments. It was developed for rangeland environments, and a lot of people, scientists, landscape scientists, know about the landscape function analysis process and method. It is a somewhat time-consuming method. You can see my previous boss there making notes on that sheet there. It has been adopted by others in lots of different environments, and it does take a little while, but it is focused on the soil surface, what's actually happening on the soil surface, how water is moving on the soil surface, and involves a transect. So normally a 50-metre transect is taken, and when we were doing these field observations, we were doing well. We would do 2 sites in a day, 2 50-metre transects, and I guess if it was a long day, we might have been able to get a 3rd site in. That's one example of scientists using in-field observations. And another example of scientists using in-field observations is measuring the health of river systems. The Land, Water and Wool project promoted the use of the rapid appraisal of riparian condition methodology. This has been used by the Malone Institute in measuring the health of the Malone Creek, and you can use it to produce data to track changes over time. And we can see with the chart there that 4 of the 5 methods that are being observed are generally improving over time. The rapid appraisal of riparian condition involves looking at different sites down the watercourse and assessing a number of different criteria. And those are 5 of the criteria. Back in 2002, the soil health card was produced for the Northern Rivers, based from a land care group, and in consultation with a number of skilled and experienced people, but particularly with other farmers. I think part of the reason that it was such a good guide for the time was because of the different people involved in producing it. And that soil health card has been developed by others into other systems. It was very practical, and you can still find it on the internet, and it uses a lot of equipment that you would find on the farm. So that you can see there that, you know, there's a coat hanger and a bit of high tensile fencing wire used to fabricate 2 tools. The rapid assessment of soil health was developed by Soil and Food. Soil and Food is one of the leading soil extension consulting businesses in Australia, and David Hardwick put this together as part of a project in Queensland. And you can see there the materials that might be required for that. It is, again, a transect-based system, so down a line with a tape. The rapid assessment of soil health has also been developed into a more comprehensive version, which is the holistic assessment of soil health. You could look both of those things up if you want to. There are now a few different systems where you can get a consultant or somebody to come to your property and do this for you. A few of the farmers in our network are using the ecological outcome verification process, which is managed by the Australian Holistic Management Co-op in conjunction with the Savory Institute. One of the virtues of this type of approach is that you don't have to go out there and do it yourself, but and you might be able to get a price premium by differentiating your product by showing that it has a certain quality to it. But one of the disadvantages is that you don't actually have to go out there and do it and spend the time noticing more things about your soil and what's happening in the landscape. Now, there's a few different options in this respect, and they will all, including doing it yourself, providing you can build up some data, be likely to be of use when we have more quality assurance and verification processes coming down the line towards farmers. So that's something to consider. At Soils for Life, we have been using field observations with farmers in 2 projects. The first project was the Resilient Soils and Landscapes with the Riverina Local Land Services, which ran from 2021 to 2023. We used 6 field indicators. We paired those field indicators with in-depth lab tests, and we brought the farmers in that project together for monthly discussions on Zoom, where they could share their experiences, encouraging people to make the observations 4 times a year at the same site where we had taken the soils for lab tests. We also launched the Soil Health Challenge last year, and it was based on 5 very easy indicators, including 2 taking a photo, so quite rapid, and encouraged people to commit to doing those 5 indicators, or as many as they could get to of those indicators, every 6 months, and sharing their pictures in a Facebook group so that they could learn from each other. And we learned a few things in this project, and it has now become the Soil Health Monitoring Community, which is a group of 200 people on Facebook, and you can join that community. You can download the guide with the 5 easy steps and get started. That's the overview that I wanted to give, and Now we are going to hear from Sarah Fee. Sarah Fee is our agroecologist at Soils for Life, and she has her own consulting business supporting farmers mainly in cropping systems. Over to you, Sarah.
I better unmute myself. That might help. Thank you, James. Great introduction. And welcome, everybody. Great to see a good lineup here tonight. And I guess, yes, as an agroecologist, which I've evolved to using that definition now, formerly an agronomist, but I really now, my life in the last couple of decades, it's really about that holistic view, bringing all aspects to what we're observing into play to help with decision making. And I, whilst doing one-on-one consulting activities, I also do enjoy bringing groups together, and whether it's small groups or events as well. So, and I do really encourage for these sorts of activities, to consider a little group in your area, or and when I show up on farm, I often encourage whatever family members or team members can come out with us, because there's so much richer learning experience with all these different sets of eyes having, observing in the opportunity, and bringing in the young, like a keen young observer here in the red hat, really enjoying a water infiltration test. It helps us all come to with that inner child, and helps explore, build our curiosity that we really want to bring to this sort of activity. Next slide. James, do you have to? Yep, thank you. I guess often I might find myself visiting someone in the early day, right at the beginning, it might have been a query about doing some soil testing initially, that I come on farm. But even that, whilst yes, time is always something we really need to think about and keep our minds on, it's a fantastic opportunity to do as many of these other observations that we can do at that one time, because it helps also for that more richer understanding of the data when we get the soil test results, if we really make some good observations at the same time. So, even the decision of why we're sampling and where we're sampling and when we're sampling, all those things are coming from previous experiences, previous curiosities that you've had, but it also informs what type of sample, where we're going to sample. If you actually establish that question, what am I wanting to know? What is it that I'm wanting to understand? And whether it's, a challenge in production that you've seen there, or, or it really performs really, really well there, but not so much over here. How do we unpack this? So whilst we're exploring that, it's a great time to actually gather other data, like, that we might have in the HASH program, or those other programs that James outlined, because it's making the most of that opportunity. So like here, whilst we were taking soil samples, I also brought out the gear to lie a core out so that we could actually explore that, get our hands right into those cores, see how deep the roots were going through those cores, have a look at the changes in colours that we're seeing there in the different profiles, and getting curious about what's going on there. Could we feel the compaction whilst playing with those cores? And it really just opens people's, horizon to so much more curiosity to what's going on under your feet. And I guess some of the key things that might pop up when you start having a bit more of a dig in your soil, is also something that you can explore with the penetrometer. Now, I find this a fantastic tool to get farmers using. One of my favourite tools to pull out at a field day or any time really, and to get whoever's there really involved in having a look at that, and the data from that. So you know, the amount of pressure that we have to push onto the penetrometer. You know, ideally we want to see on this great scale here that David Von Pine puts on his penetrometers, you know, ideally we want to be able to be keeping ourselves in the green. But when you start to play with this machine, you know, piece of equipment, it's not only telling you how much moisture might be in the profile or where compaction layers are, but you can actually start exploring different plants and actually going down through the center of different plants and seeing what different plants in your field are doing and what impact that they're having on the soil. And you know, and getting an understanding of the value of different crops in your rotation to actually working, say, if you've identified that you've got a compaction layer. We jump through to the next slide, please, James, where, you know, I guess we have these other great visuals. So the plants themselves speaking to us as to what's going on. And you know, the plant there, the radish with the really whoopy root system, helping us understand that, yes, it's had a bit of a tough time. And, you know, that could take a bit more exploration, because whilst we might think it was tough at the top, it was actually, you know, also a bit tough on the bottom, so tight in the soil. So it was popping it up out of the soil as well. So, you know, once we make these observations, we find ourselves digging in deeper and seeing what else is happening if, you know, if we get boots on the ground and out there. Whereas, you know, this other tillage radish, as we can see with holding it up against the penetrometer, had 30 centimeters. It was going down nice and straight. So there's all these different ways that we can support ourselves in observations. The next one, James. Thank you. Whoop. And again, here a bit of a tougher soil. I guess I've just chosen tonight to try and show you some of the fun things that I've observed or photos that I've had sent to me over the years of different challenging paddocks I've been into. But, you know, here, the left-hand side, the soil in my hand, you know, really tight capped soil there. But a plant has still managed to make its way through. So whilst we can observe and the depth of this capping and consider some of our choices for management here and what might be going on, the collapsing of that, you know, of that layer, and lots of, you know, challenges in terms of water infiltration and whatnot. It's always great also to observe what plants are managing to make it through, and how can we either encourage them or utilize others in our repertoire of a similar family. And I guess, you know, the plant here on the right, the Kena, you know, really showing that's that same location, whilst it again has got some really crazy root systems going on and showing that we've got that compaction layer. It's working on it. It's also again this observing of the plants that we're seeing. There's a salinity issue here as well. We get to see it's literally the salt crystals on these leaves and things. So it's about getting, you know, curious about all these different things that we're seeing and how can they be helping us calibrate our eyes into the future. And I guess, you know, more and more we're getting to understand the importance of looking underneath the soil and looking for these great zones of the rhizosheaths, and understand, you know, wanting these soils to be stuck on these root systems so that we know that we've got biological communities forming there, great, you know, glues and processes happening in that little environment, that community within a community occurring. That's knowing that we're engaging nutrient acquisition processes that we might not see if we had clear white root systems that haven't got that interaction. So we know we're starting to make inroads in our biological association. And often I'll hear people go, yeah, I've got legumes in my rotation, so therefore I'm working on my nitrogen. But not often enough people are looking, not often enough are people digging up these plants and actually seeing, do we have nice pink, healthy nodules? You know, because we actually need to see whether they're actually forming, how many we're seeing in the root system, and actually if they are nice and pink and active. Therefore, we know they are making nitrogen. If they're not, then we have to dig a bit deeper. And I guess that's for a whole nother probably presentation, or I'll be here all night, James. So yeah, jump on to the next one. And like that we've had in the Soil Health Challenge, so much benefit for digging around in the soil and having a look to see what organisms are down there. And true, often we might have done that from more of a, oh, well, who might be chewing off the roots of our plants, who might we might need to guard up against. But when we're bringing the whole of management together, we want to see the diversity of who is there. Is there other organisms there to keep, say, this wireworm larva in check? Who else is there? Is he actually healthy, or is he actually got a virus and unwell? And very, very small, but very excitedly, there's actually earthworms there in Will's hands there. So, having a good look for earthworms. So good to see earthworms, because then you've got the complexity of the biological community building, because they feed on that diversity of biological community. So you need that complexity to be able to host and have them there doing so many wonderful functional landscape processes for us in terms of aeration and cycling of organic matter and just so many things. So, get down on your knees, get right in amongst that clod of dirt that you, dig up with your shovel, and really have a good look to see who's there, and get curious about why are they there? What could they be doing? And it's really important to, we're often trialing different things and exploring and wondering about different things, and it's really important to make sure that you actually go out and have a look. Keep your monitoring up, have a look at the situation before you try some things, and then make sure you circle back and have a look. So the left-hand picture with the medic there, tough soil. Look at that compaction layer that literally just, swung away with the roots still going through. So that's early days in multi-species trial. So still a ways to go, but it was great to see that the root systems were actually managing to get themselves through that, and great to see that multi-species, had been incorporated there. The middle photo, we're putting on friendly fert, we're putting on pelletized manure. How is it showing up? So you can literally see there the little, like a dash line of those pellets showing up in the system. And interestingly, there we actually had baby tiny little earthworms also coming to life right around those little pellets of pelletized poultry manure. And then, we're doing seed dressing. So dig up your seedlings. Are we actually getting good outcomes? Are we having the formation of beautiful rhizome sheaths, like you see here in this picture on the shovel? But really important to, use this monitoring to check in. Am I having the outcomes that I'm desiring? I guess to wrap up there, for me, heading on farm, these are the essentials that I like to have, and I encourage those that I'm working with to, as often as possible. And I guess we might be doing monitoring often spring and autumn, but with crops, especially up my way, we can have something in the ground nearly all year round. It is getting in that habit of having a lot of these tools in the ute with you, and grab that opportunity to go and explore. When something's not quite looking how you'd like it to be, grab that moment and jump out, do a Brix reading, check what the sugar levels are going, and keep the data flowing in for yourself in terms of to support your decisions. And I'm constantly getting text messages with all sorts of numbers coming my way, and with people making observations, and all this helps us make that next decision. So, you know, really encourage people to get out into their paddock as more often, be really curious. You know, don't have preconceived ideas about what it is that you think that you're looking at. Be willing to sort of unpack that a little bit more. And yeah, always have your shovel, and then all these other, you know, wonderful tools, penetrometer, infiltration kit, and, you know, being able to test our aggregate stability. I mean, you can simply even test aggregate stability if you push for time with a little clod of soil in your hand and pour some water on and see whether the water flows clear or is all cloudy. So, you know, and when you have some more time down the track, go and set it up a bit more robustly. But, you know, create opportunities for yourself to explore your soils and see how things are changing according to your management. And yeah, you know, if it's getting really hot, always have bags or buckets or something in the car to be able to grab some samples and take them home for later, and bring the children and all the family into the exploration and do it together. It makes it a bit more fun. Yeah. Thank you, James.
Thank you, Sarah. Thanks very much for that. I'm looking forward to getting into some questions and answers at the end. But I'm going to stop sharing the slides now and invite Campbell to share his slides. Just bear with us whilst we, you get to see a little bit of how the sausage is made. We know that not everybody is perfect, and we're not perfect, so we're hoping to normalize that. And we're going to hear from Campbell in a minute. Campbell Mercer is the man behind Manna Hill Estate, which is an organic olive orchard in Victoria. He is passionate about regenerative farming, regenerating the land, rural communities, and supporting our deep connection to nature. Whilst Campbell gets his slides up, I'm just going to remind people that the point of showing all the scientists using these methods is to show the link between the usefulness of the data as understood by people who look at landscapes from a scientific lens, and then see how we have translated that into tools that are practical for farmers to use.
Are you able to, Campbell? Or
well, I think I'm sharing. I think
we can't see them just yet.
Yeah, they haven't come up yet.
Okay, let me see. I thought I had. Okay, I'll try. See, I'll try again. Let's see.
Here we go. Yep.
Okay. Let me see. Screen sharing. Sorry, I'm just trying to go to full screen. We'll get there. We still there?
No, just yet. There we are.
Yep.
Excellent. Okay. Yeah, hello, my name's Campbell Mercer. As James indicated, I run an olive grove. I have some sheep, which I use from time to time as part of a grazing strategy. I also have agroforestry. We're just southeast of Ballarat in Victoria. Historically, so 20 years ago, you probably said that we had 700 mil of rainfall a year. That's falling, and in the last 10 years, it's probably down to 620. And so far this year, we've had 450, and 50 of that's fallen in the last 10 days or so, which is, given that we have a winter rainfall, that's sort of really unusual. I'm certified biodynamic, certified organic, and certified regenerative with a global certifier. So that's a little bit about the farm. In terms of bit of a history, we've been here for quite a while. So when we started off our soil test on the left there, this was taken a few years after we started. Probably looks a lot like a lot of people's soil tests. It's so it's short of basically everything other than some of the heavy metals and hydrogen, which means that it's really, really acidic. We have Ordovician soils, always good to get an understanding of where your soils, when they were laid down. So these are some of the oldest soils on the east coast of Australia. And so they're about 450 to 500 million years old. And to put that in perspective, Gondwana land started breaking up about 200 million years ago. So these predate Gondwana land by quite some time. Soil pH 4.6, which is, again, not unusual for these soils. Soil organic matter when we got here was around 3.9, soil carbon about 2%. Really, really shallow topsoil, less than 100 mil of topsoil, and really poor plant biodiversity, meaning we basically had crops of capeweed and bentgrass. So why do I monitor? And yeah, probably much less scientific than some of the things you've heard about. Probably my principal reason for monitoring is to determine the impact of my management practices, which I call controllables, on soil health, and work out where I should put my resources, because we're all limited resources. So where should I put them? What should I do more of? And is there a better way of achieving that? And in many cases, the best thing to do is stop doing something. Assess the impact of external environmental conditions. So these are it's like your non-controllables to some extent, principally rainfall. We're a dry land grove, so we don't have irrigation. So what falls out of the sky is what we get, and that can have a huge impact on soil health. So understanding what that is, can I, and in many cases do I need to, mitigate the impact of too much or too little water at various times of the year? And my experience is the results potentially aren't linear. So you don't get a nice straight line in many, and sometimes there's not a direct cause effect. So there's a lot going on in the soil, and I certainly don't understand all of it, and or even not most of it, but you can see things trending over time, and that's one of the main things I get from it, is not the point in time soil tests that I do, but what happens over time and just looking at what happens. Monitoring, yeah, my kit's really, really simple, much simpler than Sarah's. By the way, we have way too much stone in our soil to be able to use a penetrometer. So I would like to be able to, but that's not feasible. So I just have a watering can and a bit of PVC tube, bit of square bit of timber. So that just throw that on the ground to work out what, number of species and that sort of stuff. And a shovel. That's pretty much it. Pretty simple. To all intents and purposes, I look at, I won't go through all of those in terms of the things that we look at. I do take, as I go through, a series of soil samples, and the last two things on the list there, pH and microbe health, I assess with the soil samples, but everything else I'm pretty much getting from the tools that you see there on the page. So pretty simple. The advantage of being simple is it's fast. So I can do my test plots. I walk because that always, as you walk across the paddock, you get an idea of what's going on regardless. And so, for example, just in this particular photo, I would say there's too much clover in it. And the reason I say that is that it's more than 30% of the square. And my experience is that once you get more than 30%, the clover will dry off when we get into the drier season. And if you're not careful, you end up with bare soil. So I do try to limit things like clovers to less than 30%. Doesn't always happen. So in terms of improvements in soil depth, so on the left there, you can see that's what our soil looked at the start. You can see there's quite a distinctive B horizon at around about 100 millimeters. It was a bit less than that. And now I can put a shovel in once I can get around some of the stones, and my topsoil goes at least 300 millimeters. And you know, and you can sort of see this in terms of history over time. So this is the advantage of the trend analysis rather than just point in time. It doesn't tell you very much, but by looking at it consistently over time, you can start to see things are changing, things that work for you, things that aren't working for you across a number of different plots, and decide whether you need to change your management approach or keep doing what you're doing, or do it faster, or whatever. So yeah, really great to just dig a shovel full of soil and see what's going on. Water infiltration is another thing. This is probably my most variable. And so this is what you'd sort of like to see, that, yep, your water infiltration improves over time as you take various data points. I find that the spring and autumn ones, I try to make an appointment with myself at the equinox. It's just a nice, handy diary time for me to remember to go out and do a soil test. It only takes me about an hour and a half to walk around the place, that do my samples. And yeah, I just use the equinox. I do move it a bit because sometimes the equinox is not the best time. You find that we've had a really dry spell during the summer, and we haven't had any rain. And in terms of looking for, some of your macro critters, you're not going to see very much. And if you're doing a microbiology test, you're not going to see very much if the soil is still dry. So I do move it around a little bit just so that I get an idea of what's really happening. But I try to keep to those sort of times to some extent. But it doesn't always look like that. And I'll just show you a couple of other examples. I won't go into a huge amount of detail. But the one on the left is sort of the reverse of what you'd hope to see. It starts off, the water infiltration is amazing, nearly 2 meters per hour of water infiltration. So you'd have to be really happy about that. And then it just crashes. And yeah, it's so it doesn't always work. And the one on yeah, basically that particular area is really low. And in October 21, it actually was nearly flooded. And in December 22, it did actually flood. So I didn't do a water infiltration test because there was a centimetre of water across the surface. So yeah, you weren't going to get any water going in under those circumstances. And the one on the right, yeah, it's started off okay, crashed, put in a summer mixed species. It really improved. So you sort of think, okay, I'm on the right track. And then surprise, surprise, it crashes after that. So again, it's all about, as Sarah said, it's about being curious. What's happening? What's going on? Why is your soil doing that? What do you need change as a soil manager in order to address some of those things? Clearly, you're doing some things that aren't working, or the external environment is creating a situation, and do you need to react to that in some way? pH, I think pH is well worth spending some time on. There's just so much soil microbiology, so many minerals that become available depending on your soil pH. it is one of those absolute keystone elements. So worth investing in a decent pH meter, and figuring out how to do it yourself, because yeah, it really does make big difference. I know some people are using test strips and trying to determine from color, but pH is actually a logarithmic scale. So when we started off, we went from 4.6 to 5. Doesn't sound like much of a change, but in actual fact, it's 2.5 times less acidic because it's a pH 10 scale. So to put that in perspective, we started off with putting lime on at 2 tonnes per hectare, about the old tonne to the acre. Did that for 3 years and got the pH up a bit. And then I sat down and thought about it. And okay, so we'd gone from 4.6 to a bit over 5. So we'd improved the pH, increased or decreased the amount of acid in the soil by a factor of 2.5. My target initially was get it up somewhere near 7. To go from 5 to 6, that's a factor of 10. To go from 5 to 7, that's a factor of 100 because it's a pH scale. So imagine how much lime you're going to have to pour on to get that sort of result. It's completely uneconomic. There's no way that's going to work. So I figured that out in 2005 and said, no, we're not doing this. So I played around over the next 10 years, trying different things, composts and deep ripping and doing all sorts of things. As you can see, pretty much with no effect, because I kept measuring, kept doing things, nothing happened. In 2018, I started focusing on soil biology, and I started seeing some quite dramatic results in terms of soil pH. And you can see the list on the right-hand side there. Real focus on soil biology, and my pH has been improving and improving ever since. It's now up around 6.7, was 6.5 last year. Under Albrecht's principles, you want to stick around about 6.4, so maybe I've overshot slightly, but no, I'm not overly concerned. Olive trees like a slightly alkaline soil in any case. So, but I'm really happy around 6.5. And that's all been done with soil biology. I haven't added any lime since 2005. So yeah, there are things that you can do much cheaper than putting lime on, and you can make a huge difference in terms of what's happening to your soil. Microbial activity, that's the other thing that I measure. I use a microbiometer to do that. Tests cost you take a little sample, you mix some stuff that you get, and you take a photograph with your phone, and it tells you your fungal to bacteria ratio and your total microbial count. And yeah, I think this is probably one of the other key elements that I really focus on, because weeds really like a bacterially dominated soil, which and most of Australia's soils are very bacterially dominated. A rainforest is very fungal dominated, so that's about 1,000 to 1 the other way. And so I'm really targeting a 1 to 3 fungal to bacterial ratio. And as you can see, when I started measuring this in 22, it was pretty low. It was around about 0.2. My total microbial count was just a bit over 100. And anything considered below 200, by the way, is very poor. Between 3 and 400, or 2 and 300 is poor. 3 to 400 is average. 4 to 500 is good. Above 500 is exceptional. And you start getting composts starting at about a microbial count of about 800. So yeah, I took a test earlier this year, and it was right up there. And since falling back, we've had a drought down here, and that's had a bit of a hit on the fungal population, because you can see that the fungal to bacteria ratio has fallen off as well. So yeah, I'll be really interested to keep doing some of the stuff that's going to really improve that over time. So that's about what I measure. James, do you want to take the screen back?
Thanks very much, Campbell. I noticed that we've got a question in the chat. We'll come back to that question when we come to the Q&A, but it's a good reminder for people, if they do have any questions that come to them, just pop them in the chat, and then we'll get to them as soon as we can. I'm going to start sharing Bert's presentation, and if you could let me know if you can see that clearly now.
You're on mute, Bert.
If anybody else could let me know
Here
if they could see that.
There we go.
I'm just going to introduce Bert. Bert is a grazier from near Hay in New South Wales. Back in 1994, the Soil Conservation Service began collecting data, annual data for their range assessment program on his property, Biodynamic. Bert will correct me if I've got the pronunciation wrong. And since this time, Bert's been following up with a range of ongoing field assessments. Biodynamic was recently part of a 3-year program with Soils for Life, and you can read the case study on our website. We're looking forward to your insights, Bert.
I was just going to ask if you could do the other slideshow first, though, James.
The other slideshow.
Yeah, about us.
All right. I don't have that one. Would it be all right if we?
No, that's all right.
Yeah,
that's fine. We'll go through this one.
Yeah.
So we're southeast of Hay, on a 7,000 hectare property. It's all native grassland, and had been managed for merino sheep breeding for probably 100 years, 120 years. It was a much bigger property than it is today, but when my grandfather owned it, it was over probably 25, 30,000 hectares. So yeah, we're one of the last families living on the land of the Matthews family. But my health or soil journey came about after 2 rather major activities. We had a bushfire in 1990, and 2/3 of our land was burnt on a very, very hot fire. They say cool burning's great, but a very, very hot fire at 10 o'clock in the morning was 45 degrees and a 50-kilometre-hour northwesterly wind was blowing. So we lost a lot of sheep and a lot of our ground cover in that particular episode. I don't know if anyone remembers, but back in 91, sheep weren't worth a lot of money. There was they were actually digging pits and burying them, but yeah, we had lost our opportunity to produce income. So yeah, it was devastating for us. But anyway, going on, recovering from that phase, and then starting to identify how many weeds that we were getting initially when the grasses started to come back, or when the fodder was starting to grow again, started me on a journey of questioning why the southwest corner of a paddock was so degraded, or why the sand dunes running through the middle of a paddock were so degraded. And yeah, so it put me on a journey of learning that I wanted to know about soil for a start. And so I did a biology course with Elaine Ingham's, the course she does over there. And then I bought a microscope and started to understand that soil was alive and we needed more living. The fact that we live in a brittle environment does tell us that we only have limited opportunity to allow our bacteria to work. So it's important that we give them the conditions that they need to happen. So this was yesterday, this picture you see there, and we actually did get a shower of rain. So I took a quick photo of that rainbow because they don't occur very often. So I can go to the next slide, please, James. So the first thing I do when we get out there is identify if there's any activity of critters out there. And on the left-hand slide, you can see it's a cicada nymph. And then there's the big hole in the ground. I assume it could be a spider of some sort. Obviously not a trapdoor because there was no door over it. And quite a variety of ants. And in the right-hand picture, that was a little termite mound that had some really big black ants, but not a whole colony of them, just 2 or 3. So, yeah, that's the way they were co-evolving. Yeah, it was quite an interesting sight. Move on. So the first thing I do is throw that's about 1 metre round, that hoop, throw it down on the ground and make an assessment of how much ground cover I've got. And in that particular photo, it was nearly 95. There was only a little bit of bare ground in that, right in the foreground. You probably can't see my cursor, but anyway, it's yeah, so it's quite a lot of ground cover there. A lot of it is old feed that has not been utilised, but all those perennial grasses there have green leaves on them at the moment, and they're responding to this recent rainfall that we've had, nearly 52 millimetres since November 15. So on the left there is a grasshopper, and quite a lot of them are, as you walk through the site. And on the right, as Campbell mentioned, heavily bacterial soils we have. So every time we see a fungi fruit or anything, we love to take a photo of it. So that on a old cow pat was, yeah, good to see. So as you see, the hoop shows, and I also do an assessment of dry matter in the area. So we've estimated around 2,500 kilograms per hectare over that paddock. Moving on. So again, the slaking test and soil stability. We dig down like 5 to 10. It's always difficult to get it to break off right at those figures, but so we sort of get 5 to 10, 10 to 15, or 10 to 20, and then 20 to 30. But previously, back in February, we struggled to put the shovel in the ground. So this time it was noticeably easier, and I'm sure the moisture that we have had with the rainfall has certainly helped that. But the aggregation of the soil, the organic matter involved in it, it's noticeable that it's improved. So still a bit of slaking and a bit of slumping in there. That was about 20 minutes on the right-hand side. I think you can see the times there. 27 out to, read my glasses. Yeah, 40 minutes. So yeah, it's 20 minutes to the right-hand side. So still holding most of its form, but we obviously got some runoff there, and reminds us that we need to build organic matter in the soil by doing that test. Although we have improved it a lot, it still needs improving. Next slide. So the infiltration test, that was the way we do that. We've just bare up a bit of the grass and then knock that little PVC pipe into the ground. Again, it was much easier. Sometimes the PVC pipe gets wrecked by trying to get in the ground, but we've managed to keep that alive this time. And this, I think it's a video, this one, James, you might be able to click on that, maybe the one in the middle. That was the rainstorm yesterday, so it blew a gale for 10 minutes. I think we had about 3 or 4 mils of rain. And again, how easy it is to miss out on a rain shadow when or a rain cloud when you the guy 5 k's away missed out on that one. Moving on. Oh no, you've got the old one. I did change this over. Never mind. These
My
figures you
mistake.
can't read, but this is the way we record our records, or keep our records. So we've got the property name up the left-hand side and the location. So these first figures were in February of this year. Thank you, James. That's good. And we have taken photos, and we do make a record of where the photos are held. So I do hope one day to be able to get them all where I need them and can find them easily. But it isn't the case at the moment. So those water infiltration levels you can see have improved over time. There was yesterday afternoon when I went out there, I put the flask in the ground, and I got up to, within an hour, I just left it full of water and for an hour, and it actually, the water had infiltrated 150 millimetres an hour. But I found it quite extraordinary that it would do that. And then I went back out again this morning, 3 feet away, and got the figures of 10 millimetres down the tube after 6 minutes, and 15 millimetres down the tube after 12 minutes. So it's just extraordinary how things can change so quickly in a short space of time. So again, the number of organisms that we've seen early in the piece, we only had 5. Then it went to 8. We got a few beetles came in, ant species, and we got about 20 this time around. It's grasshoppers, cicada nymphs, ants, quite a few different ants, small, big, small and big. Some beetles, a couple of varieties of beetles, and some termites in that termite mound. So, I think that's all encouraging signs that there are other critters coming in our pastures. I haven't yet found a worm out there, but I'm figuring it might need to be a bit wetter than it is at the moment. Next slide, please. So this is the soil sample that we got at 20 centimetres, and you can see there's still quite a bit of organic matter and a lot of root volume in through there. Quite a lot of those, I think you can see 3 in that picture, of those cicada nymphs. So they obviously tunnel into the ground quite a bit, and but as I said earlier, much easier to get the shovel into the ground this time round, and I try and do it 4 times a year, do my soil assessments, and the organic matter is increasing quite high on the surface, and the roots in the soil were noticeably down to at least 20 centimetres. We didn't dig any deeper, so they could have gone further. Many holes in the clods from insects and arthropods and spiders, and it was also noticeably, and it could have well been the rain, but it was noticeably a sweet-smelling soil. So that's sort of our overall assessment from the day. Is there another one? I think that's it.
Thanks, Bert. Apologies for the technical difficulties we had there, but thank you very much for that. And now we have time to have some questions and answers. And I'm just going to go to a question, actually, Bert, that you, I believe, put in the chat. You asked whether, when Campbell noticed that the infiltration rate was quite poor, Did you notice a lot of extra runoff that was happening at that time, Campbell?
Yeah, we did have some water runoff from that particular area, but it was flowing really clear, really clear. So yeah, I'm pretty confident we weren't losing virtually any topsoil associated with that. Yeah, we basically for a very long time we've had, if not 100%, very close to 100% ground cover, either litter on the surface or actual plants on the surface. And so as a result of that, yeah, there's very little rainfall directly impacting on the soil. So we don't have a soil mobility problem.
Just a reminder, people can either put their hand up if they want to ask a question verbally or pop a question in the chat. And especially if they have, someone that they want to ask the question of, you can let us know. I'm going to read one of the questions out that we had for people when they registered. And one of these questions is from Jim Kennedy. He asked, how do we baseline for monitoring our farm improvements? Now, I'm just wondering, Sarah, is that something that you could speak to firstly?
Yeah, I'm muted. Yep. I guess it's a combination to create your baseline. I would recommend getting a baseline in terms of soil assessment at the laboratories, and making sure that you get availables and totals analysed at the laboratory. We've talked quite a bit, the others observing soil biology results as well. So you can also send away to get soil biology results. And I do like to have that in the background as well. And then you can keep looking at that in comparison, say, if you decide to use the microbiometer like Campbell was explaining, because it's good. It's always good to know who's in your community, and then check in with that microbiometer during the time. So having some assessment from laboratory analysis, but at the time, like I sort of alluded to in my presentation, making the most of that opportunity while you're doing those soil samples to also take a record of water infiltration rate at the time, what were your aggregate stabilities like down through the profile, what critters were there, and what different plant species and whatnot are there showing up at the time of sampling. Having that all recorded is a good way. And photo, a photo can talk 1,000 words. Also, when you're taking, so that all this information goes into that baseline data that you're generating for yourself, that then is a point of comparison moving forward.
Bert or Campbell, is there anything you would like to add to that? Yep.
Yeah, I guess to some extent, I didn't start out with the intention of creating a baseline per se. I just started. And I guess that's what I'd recommend, is that you just start. And if you add stuff over time because you think that's really important and you need it to make a management decision, then do that. But I would keep it really simple at the start, and just do it. And then, from that, work out, are there additional things that you might need, or there's a decision that you want to make and you need some information in order to be able to make that decision. So I guess I wouldn't focus so much on getting the absolute correct baseline. I would just start recording stuff, and add to it as you go.
Yeah, and I guess to add to that train of thought that you've jumped in, brought to that, Campbell, is that remember, it's a snapshot in time, especially with respect to, say, availables, and who you see showing up at that time and what plants. And like I think you've both alluded to, when you've been doing your assessments, there can be variability within, you know, a short distance. So, you know, even that awareness, bring that all in, you know, how much variability are you seeing, you know, when you walk the paddock, walk a transect, and know that this is about getting an understanding of you know, the functionality and what's showing up. And it's not necessarily in absolute terms, but it's giving you something to know where things are at right now. And if you do the similar assessments moving forward, then you've got that comparison that you're making. Yeah, because, you know, there is some variability in this, but actually having some observations and doing is far greater than shooting in the dark and just wondering, sort of thing.
There is an old adage to say that if you don't measure it, you can't manage it. So, yeah, I think it's good advice that just make a measurement of whatever you are, wherever you are at this point in time. We're all starting at different levels, and yeah, just got to work it out.
Thank you. I have another question in the chat. Zoe has asked, where would you start with a crusted bed, probably saline soil? How does she get started? Sounds like a management question. Would anybody be interested in speaking to that?
Yeah, I'd be happy to. Yeah, I've had a lot of that sort of soil. Bare, crusted, it had cryptograms on it, virtually no grass, and now it's got swards of perennial grasses on. So yeah, you've just generally, if there's no water going into it, you need to somehow get the water into it. So we say you shouldn't drill the soil or turn the soil at all because of the biology in the soil. But at some stage, you need to break that surface. So whether you do it with animals or a deep rip or something, yeah, you've somehow got to get moisture into the soil, and yeah, multi-species of anything is good.
Anybody else?
Well, just to reiterate that disturbance is necessary, because I mean the biology themselves also need the ability for water to flow in and aeration, you know, so to be able to go beyond, yeah, the really simple organisms that are probably actually creating hydrophobic conditions just to try and look after themselves and keep whatever moisture. Yeah, you know, it's always, when doing a disturbance, what you're doing next is also the important thing to consider, and how it is that you're getting supporting life entering back in, whether it's seed or, yeah, resources for those organisms.
Peter Watson has asked a question. He says, Campbell, you are getting great soil depth increases. I'm just wondering how you make decisions on inputs like Johnson Sioux or Biodynamic 500 or kelp, etc. How do you know which inputs to introduce, and if it's difficult to monitor?
Yeah, no, good question. To some extent, I had some of these things I've added because I saw great success with them. So BD 500, actually, Colin Seiss put me on to. He said it was the most active thing that he'd ever seen underneath a microscope in terms of compost and compost extracts. And I started off and that was quite a few years ago. And so I started off, I got some BD 500, sprayed some around on a test plot, mainly around my trees, and then it's like observed and said, okay, what's going on? And with my trees, I have to say I didn't see any impact at all, but I saw a definite line in the grass where on one side it was quite a lot greener than it was on the other, and that was essentially where the spray cut out. And so I thought, okay, this BD 500's got something to it, and so I started using that. Johnson Sioux compost. So BD 500 is really cheap per hectare. Johnson Sioux likewise. I make my own Johnson Sioux compost and do the extract. Again, it's really inexpensive, you know, probably cents, just in terms of time, probably cents per hectare. It's and so to some extent, I just sort of think that, you know, if I've got some made up, then I'll throw it in terms of a biological spray. If I'm doing a biological spray and running the tractor around, then I'll put that stuff in. I think kelp's a bit different. Kelp and fish hydrolysis, they're relatively expensive, and so I am doing leaf tissue tests and making an assessment based on the feedback that I'm getting from that as to what I'm putting on. So yeah, kelp, fish hydrolysate, amino acids, they're all relatively expensive compared to some of your compost extracts. And so I'm doing that with tissue tests, which are done during the growing season. I do about once every 2 to 3 weeks, just depending on where we are in the cycle. So yeah, I think it's, I guess I'm a big believer in John Kemp's approach, which is, you know, you've got to grow things in the soil, because the things growing in the soil are going to take down carbon into the soil, feed the microbes, and that will improve your soil. Elaine Ingham, which is where I started at, sort of comes from the other direction. She says you need to put these compost extracts and compost teas on in order to get the soil right, in order to be able to grow something. And I think John Kemp's approach is the reverse. Start growing stuff, even if it's thistles. If the only thing you can grow is thistles, then grow thistles. Don't let them go to seed, roll them and plant something into it. It's that you've got to have something that's pulling that sunlight out, that photosynthesis, and pumping that carbon into the soil and feeding the microbes. Because unless you're doing that, then you're not going to get the microbial life that's going to feed the roots, which is then going to drive them down to increase your soil depth. So the other thing I found in terms of increasing soil depth is cover crops, including some, you know, some of your deep-rooted perennials, have been really effective. Hopefully that answered the question.
Thanks, Campbell. Look, there's 2 questions I would like to ask that were submitted beforehand, then we'll come back to question and comment in the chat. One of these questions is, do you test all year round or attempt to test during dry times, for example, in summer, during summer in Western Australia? This is a question by Robin Brown. Anybody would like to address that winter test question?
I'm still building my knowledge, so I try and do it on the change of every season. So beginning of autumn, winter, spring, summer. So and if I find that I'm not getting any benefit out of one of them or more than one, well, then we'll change regime. But at the moment, that's to build up a bit of data. That's what I'm doing.
Thanks, Bert. Anybody else? Sarah, Campbell, just quickly, because we're getting close to time.
Yeah, I guess, like I said, it's holding that question, the why, in mind, why you are testing, that might inform when you might test, is probably a critical thing to think about. And great example like Bert saying there, he trying to build an understanding of what's going on in his system. So, yeah, really coming back to what it is that you're wanting to, know about, and having it that in line with your core seasons and when you've got production. So yeah, I mean, often if it's a regular thing, it might be a spring or autumn analysis according to levels of activity, because there might be moisture. But again, that's it's really your context and what you're asking, wanting to know, is a critical thing to keep in mind.
Thanks, Sarah. We have a question: how to use a micrometer for pastures? Jim Kennedy has asked this question. Can we use a micrometer? Are you using it in a grassland situation, or what are you using? Where are you
Yep,
using?
absolutely. So I'm using it in the pasture situation. You can use them in any situation really, but I think most people actually use them in a grassland situation. That's really what they're trying to achieve, because again, it's looking for that microbial count and the fungal to bacteria ratio. In grasslands, you should be around 1 to 1 with a good, healthy grassland setting, which has lots of forbs and herbs and lots of variety in it. Then, you should be targeting around that 1 to 1 fungal to bacteria ratio. And there isn't many soils in Australia that would be approaching that. Because also I'm growing trees, I probably want to be further fungal dominated again. But, in a straight grassland, absolutely, you ought to be getting around that 1 to 1 and testing for it.
Thanks, Campbell. I'm just going to quickly read a comment here from Catherine, who has worked with us at Soils for Life. Catherine suggests after the infiltration test that you've been doing, Bert, to understand why there might be some quite a bit of variability in the one space of the rates, you could carefully excavate, dig a hole, and look at the cross section there to see if there's an explanation for the why some it's running faster into the soil than others. Are you observing the what can you see there by looking in the soil? What's the diameter of your infiltrometer? Do you have reasonable ground cover and any increase in organic matter from the development of root mats or water repellents of organic waxes, etc.? All these things can have an impact on the infiltration rate. So just digging and having a little bit of a look is Catherine's suggestion. I apologise to her because I've paraphrased what she said. I'm going to go to a question from TP, who says, we're starting from scratch, and once we monitor soils, can you suggest where we can get information from so we can learn how to improve our soil and the biology in the soil? Anybody would like? Sarah, would you like to start with that?
Oh goodness me! I guess we've got quite a few resources at Soils for Life. They could go looking, but I guess it depends on what it is that they're monitoring. If it's these general assessments, there's a lot to be said for continuing your own monitoring and comparing where you are, and then doing some management and then comparing back. But in terms of wanting to position to explore how to position yourself compared to others, there always can be risk in that unless you understand the context of that information. So, but I guess there can be a great long list that we could all recommend in terms of great people to read their literature, whether it's Nicole Masters or Christine Jones' work, Dr. Christine Jones, or as Campbell talked, John Kempf. And I guess in terms of soils and whatnot, any of the Albrecht or Reams literature, it has lots of great resources there in terms of understanding your soils and how they're functioning. And I guess from a biology point, there certainly is a lot out there. In the Soil Food Web Institute is a great resource. And a fairly big rabbit hole in itself to take yourself towards. Yeah.
Campbell, would you want to add anything to that? I saw you nodding your head there.
Yeah, sorry, I just I was noting that some of those references are great. The only other one that's just as a primer really to get you excited about it is Gabe Brown's Dirt to Soil. I think that's a really good, easy to read, and hopefully get you excited about the soil journey.
As is Nicole Masters' Love of Soil. Yeah.
Yep.
Yeah, definitely.
Thanks, everybody. Thanks for coming to the webinar. Thank you for your questions and all your contributions. Thanks for bearing with us. We're human. We don't always get things 100% right, just like we know is a situation in farming. Oftentimes things don't go quite right. We're very grateful for everybody who's given a presentation tonight. Sarah Fee, Campbell Mercer, Bert, my apologies regarding the presentation, Bert. I would like to remind everybody that we have at Soils for Life assembled 5 very simple steps in a guide to get people started. That like easier thing to do is just to get started and use those guides. And if you would like to use those guides and share the experience of using them by posting your pictures in Facebook and joining a discussion in a Facebook group, there is a Facebook group that you can join called the Soil Health Monitoring Community, which we are hosting on Facebook. So I encourage you to just get started and have a fun experience learning more about your soil. Thanks everybody for coming along.